Example 4. Solve the inequality x squared minus 6x is greater than -9. All right, so this is a quadratic inequality. Okay, you see an inequality symbol, and when you scan this statement, the highest power of x you see in the whole thing is the second power. Okay, so we are going to solve this by looking at the graph of its parabola. Okay, remember what the end goal here is. We are trying to find every single value of x that makes this a true statement. Okay, all right, so first thing we need to do is rewrite the inequality. Okay, there's nothing to multiply out here, but we need to rearrange things so that one side is equal to 0. Okay, so we've got x squared minus 6x is greater than -9. Okay, and I told you it's my recommendation that when you move terms, you need to move things so that the x squared piece stays positive. Okay, so here's our x squared piece. It is positive, so I'm going to move the -9 to the left side. Okay, so on the right side, we're basically subtracting 9. So to undo that, we're going to add 9 to both sides. So this is going to tell us that x squared minus 6x plus 9 is greater than 0. Okay, remember we added here, so you do not need to flip the direction of the inequality. Okay, you only do that if you're multiplying or dividing by a negative number. Okay, so going forward in this problem, the inequality, we're going to work with this form of the inequality. X squared minus 6x plus 9 is greater than 0. Okay, so we're going to work with this. All right, so now that one side of the inequality is 0, we're going to go ahead and write down the f of x. Okay, the f of x is going to be the non-zero side. Okay, so f of x is going to be x squared minus 6x plus 9. Okay, we need to graph this. Okay, this is our parabola. Okay, you cannot graph the parabola until one side is 0. Okay, all right, so remember, this is going to be a rough sketch. Okay, it is not going to be a very elaborate parabola. Remember, for your rough sketch, you only need the fact of whether the parabola opens up or down, and you also need the x-intercepts. You don't need the y-intercept, and you also don't need the vertex. Okay, so if we look at this, I'll go ahead and identify the a, b, and c. A is the number in front of x squared, it's 1. B is the number in front of x, it's -6. C is the constant, it's +9. Okay, so since the a value is 1, the a value is bigger than 0, and so we know from that fact that this parabola is going to open upward. Okay, all right, so now we need the x-intercepts. Okay, so I'm going to come over here. Okay, so let's make a little, let's put the x-intercepts right here. So for the x-intercepts, okay, we need to set the y value equal to 0. Okay, so remember, we're looking at our function right now because that's what we're trying to graph. Okay, so f of x is the same thing as y, so we need to set that equal to 0. So we're going to get 0 is equal to x squared minus 6x plus 9. Okay, so if we solve this equation, that is going to give us the x-intercepts of this parabola. Okay, this is a quadratic equation. It's up to you. You can use the quadratic formula. You could use factoring. It's up to you. Okay, pick what you like better. Okay, this one looks pretty okay to factor, so I'm just going to use factoring on it. Okay, but again, you could plug into the quadratic formula, and the a, b, and c values are what we just identified. Okay, all right, so if we factor, okay, regardless of whether you're factoring or using the quadratic formula, one side has to be 0 before you do it. Okay, we do have one side equal to 0, so now we're going to factor the non-zero side. So I'm going to try to rewrite x squared minus 6x plus 9 as something times something. Okay, so this is one of the easier quadratics to factor, okay, because there's a 1 in front of the x squared. So anytime there is a 1 in front of the x squared, you just need to find two numbers that multiply to be the number. So they need to multiply to be +9, and they need to add up to the number in front of x, which is -6. So you just have to think of two numbers that do that, and signs are very important. So what's going to work here is going to be -3 and -3. Okay, those two numbers, if you multiply them together, -3 times -3 is +9. And then if you add them, -3 plus -3 is -6. Okay, so once you get those numbers, you just write down the factorization. Okay, this is going to break up into, we're going to have x's here, okay, because remember they're going to multiply to give you the x squared, but then you just use these numbers. Okay, it's going to be x minus 3 times x minus 3. Okay, and if you are factoring, you should check yourself, okay, to make sure you did it right. Okay, so if we, box this out or foil it, whatever you want to do to check yourself. Okay, let's box it here. X times x is x squared. X times -3 is -3x. -3 times x is -3x. And then -3 times -3 is +9. So if you write this out, combine like terms, you're going to get x squared. The -3x plus the -3x gives you -6x. And then you have a +9. That's what we started with. Okay, so multiplying it out confirms that we have factored correctly. Okay. All right. So now that we factored, we have two factors, two things that we are multiplying together. Okay. We are going to take each factor, set it to 0, and solve. Okay. They happen to be the same factor here. Okay. So you really only need to take one of the factors and set it equal to 0 because you're going to get the same thing. Okay. So if we solve this, in both cases, okay, we get that there's one x-intercept and it is at x equals 3. Okay, so if you had to write this as an ordered pair, okay, your one lone x-intercept is at the point x is 3, the y value is 0. Okay, all right, so we know the one lone x-intercept and we know that this parabola opens upward. So now we can make our rough sketch. Okay, for the rough sketch, I'm only going to put the x-axis on here. Okay, the important thing to put on here is the x-intercept. Okay, so let's say this is x equals 3. Okay, so that means the parabola is going to touch the x-axis in this one point. There is not a second x-intercept, and your parabola opens upward. Okay, so this is how you're going to draw it, like this. Okay, that's it. This is what it looks like. It hits the x-axis in that one spot at x equals 3. Okay, if you had tried something else where, if you did this, what I'm doing in red, okay, why is this wrong? Well, because if you drew it like I did in red, then you would have two x-intercepts. Yes, x equals 3 would be an x-intercept, but then there's another x-intercept over here, and you can't have that. Okay, so when you draw this parabola, the correct way to draw it is like I have in blue, where it touches the x-axis in just one spot. Okay, so now that we have our parabola, we can go and use it to solve the inequality. Okay, so remember, we're now working with the yellow version of the inequality, the one that's in the yellow box. Okay, so we're trying to solve where is x squared minus 6x plus 9 strictly greater than 0. Okay, now remember, we called x squared minus 6x plus 9, which is the left side of the inequality, we called that f of x. Okay, so this inequality is saying, where is f of x bigger than 0? Okay, you can translate that. F of x is the same thing as y. So basically, we're looking at our parabola, okay, because remember, our parabola is x squared minus 6x plus 9. That's what we graphed out. This is f of x, okay? So we're asking ourselves here, where does the parabola have positive y values? Okay, that's what we're basically trying to answer here. Okay, so over which x values does the parabola have positive y values? Okay, so when we look at this, okay, The inequality symbol is strictly bigger than, okay? So the y value cannot actually equal 0. We have to have y values that are bigger than 0, which means they're positive, okay? And we know positive y values occur above the x-axis. Okay, so basically the entire parabola is above the x-axis, except at the x-intercept. Okay, at the x-intercept, the parabola is on the x-axis. Okay, so I'm shading in purple. Okay, the purple parts, that's where the parabola is above the x-axis. This one lone intercept is the point 30. It has a y value exactly equal to 0. Okay, so that x value of 3 is not going to be a solution to the inequality, okay, because this x value has a y value equal to 0. Okay, so what you should be seeing from the parabola here, okay, the entire parabola is above the x-axis except at x equals 3. Okay, so that means, remember, the domain of a polynomial is all real numbers. You can plug in any x number you want. The parabola is defined over the entire x-axis. So for every single x value, the parabola is above the x-axis except at x equals 3. Okay, so that means the solution set here is going to be, and remember, solution set, we're talking about every single x value that you can plug in to make this a true statement. Okay, the solution set is going to be all x values, so all real numbers, except x equals 3. Okay, now how do you write that in interval notation? Okay, well, if you think about this, okay, let's look at the left side of the parabola here. Okay, this is occurring for x values strictly less than 3. Okay, so from over negative x values up until 3. Okay, and then we don't want to include 3, so we put a parentheses to throw it out. But then we pick up on the other side of the x-intercept, and that's going to give you the right side of the parabola. The right side of the parabola starts on the other side of x equals 3. We don't want to include 3. And it goes over the positive x values. Okay, so this is how you can write in interval notation all real numbers except for 3. Okay, so basically any x value in the world, decimals and fractions included, are going to make this inequality a true statement except x equals 3 itself. Okay, and you can check this. Okay, watch what happens if I plug in x equals 3. Okay, I'm going to get x squared, so 3 squared, minus 6 times x, so 6 times 3. Is that greater than negative 9? Well, if we simplify, we're going to get 9 minus 18 is greater than negative 9. We're going to get negative 9 is greater than negative 9. That is a false statement, okay, because negative 9 is not bigger than itself. It's equal to itself. So negative 9 is bigger than negative 9 is not true, okay? But if you try other things, other x values, as long as that x value is not 3, if you plug it into your original inequality, you should get a true statement.